Like a launcher, yeah, like a launcher. And some fat bees, short bees.
All right, can you hear me?
Sure.
I think I can hear myself, so we're good. All right. Thank you, everyone, for coming. See, we have a little bit of a sparse crowd. I assume people were eating too much candy last night, a little hungover today. And if my voice gets a little raspy, I was dressed as Batman yesterday, and I spent much of the evening talking like this. So sorry if you can't hear me very well. Today we talk about games. Anyone in the room a gamer? How many gamers do we have in the room? Few? Lots. Awesome. All right. Perfect. So then you guys are as nerdy as I am. So first let me introduce myself really briefly. My name is Justin St. Clair. As you can see, I'm a senior business development manager. I work in the Windows division. My job is essentially to work with the top game development organizations in the world, as well as a lot of startups and smaller organizations, to make them successful on the Windows platform. That's inclusive of Internet Explorer, Windows Live, which is inclusive of SkyDrive, and then clearly Windows. Today, we're going to talk about reimagining gaming scenarios. And to help me, I brought three of the top game development organizations in the world, Arcadium, Halfbrick, and Unity. And to be clear, I'm far less exciting than they are, so I will try to wrap up quickly and hand off the stage to them. But first, my job is to set the stage. In setting the stage, what I want to do is truly spark your imagination. I want the folks in the room, especially those who are gamers, to think about, what does the next generation of gaming look like? How do you reimagine gaming? So, reimagining gaming scenarios. PC gaming. Well, before you can really figure out, what's PC gaming, you have to ask yourself, what is a PC? We're in a whole new world. Which of these is a PC? Is it the all-in-one 27-inch TV PC? Is it the detachable thing there, or the whatever this is that has a kickstand and looks like you can take it off as well, or just a standard netbook, or I think that's called a Yoga, or there's a multitude of new form factors that change how we define what gaming is. So as a result, then we have to ask, what is PC gaming? I will, in this one instance, read you the slide because I think it's important as we try to wrap our heads around what the next generation of gaming looks like. And so this is a quote from the Register. Microsoft has apparently elected to take a much riskier and gutsier approach, turn Windows 8 into a serious gaming platform. Microsoft can't help but get into PC gaming in a big way because there's no such thing as PC gaming or tablet gaming or mobile gaming. It's all the same thing. So again, we have to ask ourselves, what is PC gaming? If you're going to reimagine, if you're going to be on the forefront of developing the next generation of games that millions and potentially billions of people across the world will use, how do you do that? There's a whole range of new gaming scenarios. You might have a single device, a single game. You have your tablet, and you're at work, and it's docked, and you have, if you're me, ginormous 27-inch screen surrounding you, and you're playing your game there. Then you pick it up, and you're walking to the bus, and you're playing it on your tablet. And then you get home, and you use the power of DLNA to play it to your screen. And now you're at the big screen TV at home playing a game. You might have a single game and multiple inputs. You might have a keyboard and mouse. You might have touch. You might have a game controller. I don't know if you guys saw the demo that Steve Guggenheimer did at the Build keynote the other day, where he was playing Agent P, and then he plugged in an Xbox controller and started playing it that way. You may have been to other sessions where one of my colleagues demoed a game where you could use accelerometer, and then you could start using touch, and then you could plug it in to a keyboard and mouse and start doing that, or you could use a game controller, etc. So there's multitudes of new gaming scenarios where you have to think through what happens with the dawn of Windows 8, where suddenly there are multiple people in a single house who have tablets. What does that sort of gaming experience look like? And actually, single place, multiple tablets, the way I like to think about that is, what do the LAN parties of the future look like? And again, if you're an old school gamer like me, and you used to have like these massive desktops that you carried in your truck or whatever it was to these kind of nerdy gatherings, and then everyone sat around and connected to LAN. So what does the new era look like? Because there's still going to be, I'm still a big nerd, so I still have a huge server at home that I use to play games on, and I will still bring that to LAN parties. But then if the gentleman next to me has a tablet, how do we make sure there's parity in terms of gaming experience? How can we make sure that if it's a shooter, he gets just as many headshots, or she is able to navigate around the map just as quickly as I am? So again, we have to kind of change our thinking around what is gaming? How do we support gaming scenarios? Similarly, you have these new sort of multi-context gaming scenarios that really challenge the game itself. And so this is a good example of, if you're developing the game, not even just simply from a gameplay perspective and a sort of a game experience perspective, but how do you change your game to make sure that when it's pushing the pixels out, that it does just as well on a 10-inch tablet as it does on a multi-screen display at someone's office, as it does on that, if you're at my house, 60-inch screen, their TV. Similarly, the touch keyboard, mouse, sensors, and gamepads. And then finally, what do you do if your single game is going to be played on a whole bunch of different types of devices? It's going to have different aspect ratios, it's going to have different resolutions, etc. So again, the key is the best games go where you go and play the way you like to play, without compromise. A gamer shouldn't feel like, oh, I can't play that game on my laptop because it's really meant for a tablet. And so again, that becomes interesting in the context of making sure the gamers are having the best experience on your game wherever they happen to be. Cross-device gaming. So again, we talked a little bit about LAN parties. What do you do in the context of multiple devices that have different sensors and different inputs? How can you actually not just say, well, how do I make sure the gameplay is there and we maintain consistency and competitiveness across devices, but how can you actually explore new scenarios when it comes to people using NFC to tap their devices together and start a multiplayer game? Or we have GPS. What if we're in a whole bunch of different locations and there's a game that really centers on GPS and people can be at a park somewhere and have their game enhanced that way? Again, DLNA, all these new technologies. And then this is one of my favorites. Working while playing, playing while working, playing while playing. Like, again, I don't know if you guys have seen, I hope you have, the snap functionality. What does it mean? How do you make your game engaging? And how do you keep users engaged if they have the game snapped to one side of the screen, and then meanwhile they're watching a game, like a sports event or a TV show? How do you use these new affordances, live tiles, toast notifications, to bring the user back into your game? Because to be clear, if you're a game developer, you want engagement, whether you monetize through in-app purchases and you want to make sure that people are coming in and buying the next cool thing, or you're simply a social game and you want to make sure that when somebody plants a new who knows what type of crop or whatever it happens to be, that they come back in and take action in your game. So again, you must think through how you actually keep the distracted gamer engaged. And then finally, we introduce new gaming business models. And this, again, is actually where I think a lot of interesting things happen for game developers and game service developers, really. Certainly, we have a robust and powerful commerce engine with the Windows Store. I assume you guys know that it supports in-app purchases, time-based trials, etc. But we also have this interesting thing called third-party commerce providers. And so suddenly, you have to ask yourself the question, what do you do if you, for example, have an app that provides a user with multiple commerce options, but you want to maintain an inventory across all those commerce options? Right? And so you're not going to simply use, let's say, the Microsoft Commerce Engine or the PayPal Commerce Engine or whatever happens to be, and have there be a one-to-one mapping between if they purchase something on that Commerce Engine, then we track it through that. You suddenly are in a situation where potentially within your single game, but across commerce providers, across multiple games, across multiple commerce providers, potentially across multiple platforms, across multiple commerce providers, you have to be thinking through how do you actually address those scenarios. And interestingly enough, I think it becomes an opportunity for people to think about how do they actually then develop new economies. Like, can you be a service provider? Can your game and your company actually develop an inventory management service that any game in the world can use, such that if I buy a sword in this game, maybe I can use it in that game. Or maybe I go to a single location to manage my inventory across all my games, and I can purchase more things for all my games at once. And maybe I can start to use that to get economies of scale and offer discounts and discover new games and new things that I can purchase in the games that I have. And then beyond that, not only do you have to think about these new business models simply in terms of how do you leverage the power of third-party commerce, but then how do you actually do business at Windows scale? I mean, the point at which you're on a platform that will have up to 1 billion users, what do you do to ensure that the user in Romania and the user in sub-Saharan Africa and the user in Germany and the user in China is just as able to purchase, to use and to experience your application? So suddenly, it may be true that you do mobile operator billing. You have to figure out, how does that work? Can I even do that within my game? It may be true that you use, again, PayPal versus an actual credit card service. It may be true that you use credit card services, et cetera, et cetera, et cetera. And again, each of these geographies is going to have a different monetization model, most likely if you're smart about doing business at Windows scale. So again, business models, gaming scenarios, multiple devices, multiple contexts. We're in a new world. What's PC gaming? And it's really up to you guys to help us define that. And so, to some degree, we've already have a few people who have learned how to change the game on Windows. And so with that, again, I will stop taking up time and actually introduce the cool people. So the first person I will introduce is Tammy Manganello. She's with Arcadium. Arcadium has been a great partner to Microsoft for the last many months, really over a year. They developed some of the games you guys might be finding as addictive as I am finding, which is actually an unfortunate thing for my wife and my child. Minesweeper, Mahjong, Solitaire, etc. So with that, Tammy, thank you.
Thank you, Justin. Thank you very much. Hi, everybody. Oops, a little loud. Sorry about that. So yeah, Arcadium is a casual game developer. We've been in business for over 10 years, and over the last couple of years, we've delved into social and mobile gaming. It's been very exciting to grow from just 5 of us over 10 years ago to over 140 people in 3 offices worldwide now. We have a New York office that is sadly in a little bit of trouble right now, but we also have an office in the Ukraine and most recently in Toronto. We've been in a long-time partnership with Microsoft on the casual side. We've been a provider of zone games for a long time, and so when they approached us about expanding the partnership, we recognized the amazing opportunity to develop for Windows 8, and we carved out a division in Arcadium to devote to this technology. I run that division, and my day-to-day role is to ensure that we're making amazing games on this platform to get everyone addicted to them. So what are classic games? This is the fun stuff. Classic games are things that gamers and non-gamers know. Solitaire, backgammon, checkers, chess, all of that. If you don't play them on a regular basis, you've probably played them in your life, either online or offline. And they come with what I like to refer to as baggage. You know the rules. Even if there's variations on how you play it or your neighbors play it, they're familiar. They've got a huge fan base. I mean, pull out a deck of cards in an airport and start playing solitaire. Everybody's going to know what you're doing. They're just the games that we know and love before technology came along and introduced us to a lot of new and exciting things. So today, with modern gameplay and modern devices, it's all changed. We can get our gaming fix in so many ways now. Mobile, tablet, Facebook, console, PC, it's everywhere. And I'm taking it with me. Waiting online, playing a game, commuting to work, playing a game, sitting in a boring meeting, playing a game. It's anywhere and everywhere. And these games, we expect the same high quality of these games, no matter where we're playing them, on the device we're playing them. So it's not just console anymore that has the amazing graphics and the sound design and the animations. I expect that on my tablet. I expect that on my phone. And I want that engaging experience. And the games today, we talk about social, a lot of people think about Facebook, but people want to share what they're doing in their games. They want to share, hey, I just unlocked this great achievement, or, oh, I finally beat my high score. So there's a social aspect to the way that we game today, especially since I can update what I'm doing from wherever I am. So the challenge And the opportunity for Arcadium was to redesign Solitaire, Minesweeper, and Mahjong for the Windows 8 platform. I mean, come on. We're a casual game developer. How freaking exciting is that? Like, it's Solitaire. And I've made so many versions of Solitaire in my life that it's absolutely ridiculous. But never on a platform like this, and never to a scale and a reach like this. And why not make these games that people, millions upon millions of people play every day, why not make them fun, engaging, and something that when you see them, you're like, I want to play that. Wow, that's not what I thought it was. So why not make these games fun? So before we could start making them fun, we needed to do a deep dive into Windows 8. And Arcadium has always been a Microsoft shop, but we were primarily Flash and .NET, and a few other things thrown in from time to time as the need arose. But we'd never worked with XAML, we didn't work with DirectX, we didn't do any of that. But having a huge team of back-end engineers and .NET engineers, we set out to start forming a core technology team. We sent people to Build last year. Anybody who couldn't go to Build, we sent them to Channel 9 to watch the broadcast, and really started just learning what this new system was about. And the team we formed the first team we formed was a core tech team. And these engineers were building components and libraries that could be used across all the games that we're going to develop. And there's two benefits to that, which most of you probably already know. One, you get reusable code, yay. And number two, it allows our game developers to focus on coding for their game and not worrying about, well, is my achievement going to be in there? Do I have a user logged in? All that's taken care of in the components and libraries. So being a part of Windows 8 operating system that's in development while you're working on it is one of the challenges, the biggest challenges that we have ever had as a company. It was really exciting. But I'm the first to admit that a lot of code drops were met with both a combination of a sigh of relief and a panic attack from the developers. But the tools that Microsoft has to work with Windows 8 are awesome. Visual Studio 2012, Team Server 2012, and Blend, all great. And we knew we had a support and excitement from the Microsoft team to bring these inbox games, these classic games, to life on this new platform. So, as soon as we could get documentation, we had it. As soon as somebody could help us answer a question, we had it. But lucky for you guys, it's all there now, and you can just go look it up, read it. And I strongly suggest that before you start developing for the platform, you have your engineers, you have your people read the documentation, look at the code samples, and study the forums, because it's a wealth of information. So once we're comfortable with our technology decisions, and we decided that we're building using C#, XAML, DirectX, and SharpDX for the games. We took off to figure out, okay, so what do we do with these games now? What's sacred? Throughout the design process and the development process, we kept asking ourselves, what is it about this game that makes it fun, that people expect when they open up a game of Minesweeper? Every morning I get a cup of coffee, and if my coffee doesn't taste the way I want it, I'm going somewhere else to get the cup of coffee next. Same thing with my game. If I open it up and you've screwed it up, I'm not coming back. So we knew that there were certain things we weren't going to change and didn't want to change. So we talked to the players, we talked to our target demo, we took brainstorms, we did surveys, and we asked them, what do you like about this game? What do you not like about this game? Why do you play this all the time? And we used that information as we were iterating and playtesting throughout the development cycle. We knew coming out with the Windows 8 system, we had to be one of the best of breeds. We had to be ready to compete with all the other platforms out there, and we needed to make something that players would want to come back and play. So let's talk about Minesweeper. It's a cult classic. It's been around for a long time. I consider it a classic game. The little gray boxes with the little smiley face, everybody knows them. It was ripe for refresh, and we wanted to give it an overhaul that would not stray too far from what it had always been and what the core demographic wanted, but we also wanted to make it a little more sleek and sophisticated and make it look like it belonged in the Windows 8 system. And Minesweeper, as you all probably know, you play it by right-clicking with a mouse. How do you do that without a mouse? So, a lot of our playtesting and iteration was watching how people would play the game on a tablet. Do they hold it with two hands and play with their thumbs? Do they hold it with one hand and click? There was a lot of iteration and playtesting to get that mechanic right so that when you opened up Minesweeper, you weren't suddenly met with, I don't know what this is. How do I play this? And you want it to feel as natural on a tablet as you do with a mouse. And given that, Windows 8 is going to be installed by, what did Ballmer say the other day? 800 million people, maybe? We weren't going to pass up the opportunity to expand the demographic of this game. So we have our core version, and then we created a version that I like to refer to as for the ladies, that has ladybugs. It's really cute. I mean, even if if you're not a lady, you can go check it out. But a lot of people are intimidated by Minesweeper, especially the older versions of it. So if there's any way to get people playing the game and make it more approachable, that's what we're doing. So there's a second mode in there. It's the exact same mechanic. It just happens to have grass and ladybugs in it. And then the whole time we were iterating and going through the process of developing these games, there were some crazy ideas that came out of, oh, we should do this, we could do that. And this one idea that is called Adventure Mode, and you can play it in the version that's out now, is a twist on the classic mechanic. But you're a little miner, and you're going through dungeons, and you're uncovering treasures and avoiding mummies and bats and all this other stuff. And that was a way that we were like, we can innovate on this classic game. We can innovate on this classic mechanic without, offending the core audience. So over the course of the last year, developing these 4 games for Windows 8, the best practices that we've come away with and will take forward with us as we continue to make games for Windows 8 is simplicity. And I know, come on, tell me something I don't know. But it really is true, especially with Windows 8. It's a whole new look and feel, and don't overcomplicate it to begin with. If your game doesn't require a timer, don't put it in the UI. Keep your UI clean and sleek and focused on your gameplay. Same thing with technology. Now that the operating system is out there, you want to do something, go see if it's already done for you before you decide to build it yourself. Check it out, try it, see what you can do with what they have already. You can always add complexity later, but it's really hard to get it out of there once you've got it in there. And do your research. Now that Windows 8 is live, there are so many apps and games on the store to look at and to explore and just dive into them and see why they work in the new operating system and how they've changed from maybe iterations that they were before. And remember your fan base. Remember what people expect and meet and or exceed their expectation. Don't break what's broken. You can introduce a new mechanic or a new mode of play, but do it with a way that it doesn't violate a rule that could affect a leaderboard score. You'll get hate mail for that one. And iterate and play test. I mean, we're an agile shop. We do it every sprint. But when you're looking at classic games and just games in general, you want to make sure that whether you're a fan of the game or not, that your target demo likes what you're doing. So get it out there, and especially with the tablets, just walk out on the street and hand it to somebody. You're like, what do you think of this? And then polish. This is something that, it's a small thing, but as you're designing your game and you get down to the end of the cycle and you just want to ship it and get it out, take another look at it and make sure that you've given it that high level of polish that makes it stand out a little bit more from somebody else who might be doing the same thing. If you're going to put ads in your games, think about how they organically fit into your game and they're not just slapped on and you spent all this time making it beautiful and now you've got this hideous monkey ad at the bottom of your game. So just take that little extra time. Your designers will thank you and your fans will thank you when they download your game and play it again. That's it. Thank you.
Thank you, Tammy. And again, I don't know if you guys have played it yet, but as I was saying earlier, in terms of new gaming scenarios, a distracted gamer, I don't know if you have actually played the Solitaire Collection. If you do, if you pin it to the side of the screen, the cards flip their rotation, and so you can continue to, again, do your email or PowerPoint or watch a game while you're still playing Solitaire on the left or right. Again, that's a great example. And actually, speaking of people who have innovated in that snap mode, the same is true of Fruit Ninja. And so really excited to have these guys here. Halfbrick has, again, been an amazing partner. I don't know if you guys know who they are. They do Fruit Ninja. They do Jetpack Joyride. They have some of the top games in the world. They have done some amazing things with Fruit Ninja and Jetpack Joyride on Windows 8. And with that, it's my pleasure to introduce Richard McKinney, CTO of Halfbrick.
So thanks, Justin. It's my pleasure to be here. I'm Richard McKinney, CTO of Halfbrick. We actually recently, just last week, released both Fruit Ninja and Jetpack Joyride on the Windows 8 store. We're really excited to have our games live for launch. And we actually managed to have the only 2 third-party published Xbox Live enabled games on the market at launch. So we were really excited about it. So what I do on a day-to-day basis, I'm CTO, so I manage platform direction, and I directly manage the engine and platform expansion teams. And I was pretty much in charge of the push to bring our games to Windows 8. So unlike Tammy, who got to reimagine classics for Windows 8, I got to take games that were already successful on other platforms and bring them to Windows 8 and embrace the new user interface designs and the new things that we had to offer. So just quickly, Justin did a great job about this already. So I just wanted to go over some of the things that we were really excited about with Windows 8. I mean, if you've seen the keynote, what is form factor for a Windows 8 device anymore? I don't even know what you call half of those things anymore. You've got magical transformers that you can piece together in odd ways. You've got tablets. You've got the phones. You've got desktops, laptops. There's so many different devices out there. We finally have ARM support, so you can get low-cost Windows tablets out there. And with the WinRT APIs, we're able to target all of those with just by writing it once and deploying it anywhere we want. And also, the Windows Store is finally built directly into the OS. That's really exciting for us because I'm a hardcore gamer, so I know on Windows platforms I'm going to download Steam. All my friends they know about that, but the common person doesn't necessarily. So it's great to have a place that people can go to without having to think about it. It just says store right there. So that adds to the visibility of the applications on the platform, and it's great for marketing your apps and increasing the visibility. Visibility is so important to getting noticed in a flooded marketplace. And luckily, Windows Store isn't flooded yet, so it's great the faster you guys can get out there. I should probably go ahead and apologize ahead of time. Like Justin said, I did get super excited about all the information that I have, and I wanted to share with you guys. So I've got way more than I can actually cover, so I'm just going to go through a lot of my slides really quickly. All this stuff should be available online, and you should be able to see it on the stream. But you can also just come up to us afterwards and meet to ask any questions that you've got. So I might be moving a little bit fast, might be talking a little bit fast because I'm pretty excited about all this. So we took a game that, or 2 games actually, that we've got on an enormous amount of platforms. So we probably started the efforts to move to Windows 8 years and years ago. We were originally a handheld developer for the most part. We made GBA games, DS games. We made a lot of the Avatar games. But we did a lot of work for hire. Once we started moving into doing our own IP rather than working for other people, we started looking at the right ways to move into the mobile market. And it was evident that there were so many platforms out there, so many technologies, that it was really important for us to have a flexible engine that engine was going to have to be something that we controlled so that we'd be able to add new features as we saw fit. When you look at some of the platform holders out there today, it's fairly evident that guys come to us and they say, "Oh yeah, we're going to release this new feature in a week. It'd be great if you guys could support it." And then a week goes by, it gets released, and then you start getting reviews that day, and it's like, "Oh, they don't even support this new super high glossy, awesome display yet." And it's like, we just found out about it. So, if you're using a third-party engine, hopefully those guys are on top of it, and maybe they get a little bit more advanced notice. I don't know. But sometimes we really have to rush to get tech out. So it's real important for us to control our tech and to be able to rapidly put new stuff in there. And being in control of our entire code base is extremely important to us. We don't have to tell people no when they come to us with new projects just because we're trapped in a third-party engine. Which I'll cover later, but there's definitely benefits to going that way as well. So our engine, we call it Mortar. Play off of our name Halfbrick. So we support over 15 platforms. Honestly, an exact count at this point, I don't even know. So everybody knows that we're on iOS and Android. We've clearly just moved to Windows 8. But our primary development platform is Windows 7 or XP machines, Windows Desktop. But we've also got so many more things out there. There's so many other platforms that a lot of people don't even know exist. But they might be huge in emerging markets. They might be huge in European markets or Asian markets that from a Western standpoint you may not have exposure to. So a lot of these are actually doing fairly well for us. But if we were using a different engine, if we didn't control our tech, then we wouldn't have been able to meet these opportunities. So we take great effort to make sure that we have our game code and we have our engine code. And the two, you never let your abstractions from a platform leak into your game code. So that's by far the most important thing. So for every new platform that we bring on, we add code to the engine, and we have basically base implementations of just about everything that the game code is able to use. And then when we add a new platform, they basically just get it for free. Now there's going to be platform-specific things like the live tiles, sharing support. We still build that in a cross-platform abstracted fashion, but those are things that might only affect one platform at a time. But maybe there'll be more in the future. So how does it all fit together? When you look at what makes a game engine, at the simplest core, you'd probably be looking at three items. It'd be your rendering API, your sound and music API, and the input. So for rendering APIs, we support a ton of different rendering APIs. We've got GLES1, ES2, DX9, DX11, and we pretty much just provide to the game, and a lot of this still stays internal to the engine, but we've just got abstractions around things like meshes, vertex buffers, index buffers, shaders, effects, just the common things that are going to be there across all the different rendering APIs. And when you look at a lot of them, like D3D versus D3D11 versus GLES2, they have the same concepts there. So they might be syntactically fairly different, but conceptually they're not. So when you look at the abstractions that you can wrap around all of this stuff, it's really easy to piece them together. In terms of sound and music, we've got a lot of different implementations for that as well. For Exact, we use that for 360 and desktop PC. We've also implemented Xaudio 2, which we've now used as our baseline for PC. OpenSL, OpenAL, and that pretty much covers a broad spectrum of sound and music APIs. We don't do too many terribly complicated things. We do mostly mobile development where we've got just stereo and maybe some pitch shifting and volume controls and that kind of stuff. So we don't have like crazy environmental effects. So it's easy for us to abstract our sound engine. It might be a little bit harder for some other people, but I'm sure we'll be adding to that in the future too. And then pretty much every platform has their own input API. But they're all really similar. When you look at iOS, Android, WinRT, pretty much all of them are going to give you like some way of getting like a touch input and a pointer pressed, pointer released. So we just wrap that up per platform and say, here's our touch class, and then the games can query whether a touch is pressed, or they can get an event when a touch is pressed, when it's released, query whether it's held or not. But each of these different platforms uses the same abstraction inside of the game. And then if you look at the smaller items, some of this stuff actually works cross-platform. Like File I/O, you might just be able to use the C runtime APIs, but sometimes you can do optimal things beyond that. Networking, HTTP communications, there might be a platform-specific implementation, but you're doing the same thing every time. It's like, hey, give me the contents that come back from this web page. So it's really easy to abstract a solution around that. Social networking APIs, on Windows 8, we've got the share contracts to share between people, Facebook and Twitter on our other platforms. And then you've got IAP and microtransaction systems. So talking to the Windows Store, saying like, hey, I want to buy this, or hey, I want to purchase my game, if you're upgrading from a trial, that kind of scenario. So of course, that's not all, but those are the major components. So when you're looking at moving a game from a different platform to the Windows 8 platform, those are the main things that I think you need to consider, is your rendering API, your sound API, and the input system. Everything else that we do is cross-platform C++. So we try and keep it as cross-platform as we can. We never let our game code leak into platform code. They never intermingle. So we've got an engine that lives on its own. We've got game code that lives on its own. And that game code could be implemented in a scripting language if we want. It could be implemented in Lua, Python. But most of the time, we still implement our games inside of C++. Just for performance reasons on low-end devices and various things. So, I mean, there's tons of things that you can do in a cross-platform C++ way, collision, math, UI, font system, tons of things. So we do as much as we can that way. So what if you don't have the resources to make your own engine? Well, that's what our friends at Unity will talk to you about shortly. And it's the right solution for a lot of teams out there. If you're a small company, then you might not have the resources to devote to making your own engine. But it's not necessarily as difficult as you might think. So if you're starting from scratch and you're building up a game, it might make sense, as long as you pay a little bit of attention as you're building it, to say, oh, I'm making a call into a platform-specific, like if you're making a call into a WinRT API, well, that's probably something that needs to be wrapped up. And then when you decide, oh, well, I want to port this to iOS, then you can use those same points to say, I need an abstraction on iOS there. I need an abstraction on Java, an abstraction into Java for Android there. So as long as you pay a little bit of attention, it's actually not as much effort as people sometimes make it out to be. And that's pretty much how we did it. We just built it ad hoc as we went along with a single platform and said, okay, we're making a game, but here are the things that we need. So just as we made it out, we just identified those points that we needed the abstractions. So if you've got an iOS or Android app, want Windows support, I think that's probably the common thread that I've been hearing from a lot of people. There's basically three options that you've got. You can do a standalone port, which is going to be a fast way to do it, but it's also less maintainable if you want to do cross-spectrum updates. You can do a shared code solution, which is kind of what I've been talking about, where you've got an engine there. And then you can also just port to a third-party engine like Unity. And they'll have Windows 8 support there. They'll have support for all sorts of other things, and you don't have to do the work for it. If you do go with that shared code solution, like I said, D3D11 rendering pipeline, an Xaudio 2 pipeline for your audio, the input, and that's pretty much it. As long as you're really careful that you don't write platform native code or like Objective-C as your gameplay code, you should be okay. So you're using the WinRT APIs to build your game. There's plenty of other sessions that'll be covering these, so I'll skip through that real fast. The first thing that you will notice is that the Win32 API has changed a little bit. You're going to get a little bit freaked out. I would suggest that you basically create a template C++ application and basically just chuck all your code in there. If you've got a C++ application already, just create the template, chuck your code in there, build, and watch it explode. It will happen, but it's not nearly as bad as you might think. You're going to see a lot of things like, oh, where did create file go? What am I supposed to do? Well, a lot of those things, and when we started, there wasn't the documentation out there, so we had a little bit of help from some friends at Microsoft. But a lot of the times, it's just a direct mapping from one to another. So create file is now create file 2, and it just has a few more restrictions on what things you can access. Initialize critical section doesn't exist anymore, but there's the EX version, which has been there for a while now. So as long as you're using that, you're OK. There is actually a document out there. I'm not sure exactly what it's called, but it will give you the mappings for a lot of these things. And then just a few tips and tricks. You're going to be doing a lot of asynchronous development in WinRT. I would suggest getting used to using the Lambda capture syntax. It's very important. Almost everything in the Win32 APIs or the WinRT APIs are asynchronous, and you're going to be running a lot of Lambda functions. Get used to the syntax there, and get used to using the async operations. I prefer using the completed handler rather than using PPL tasks. A lot of the presenters here seem to be saying the opposite, but for error handling purposes, which they seem to be ignoring in all of the examples that they're showing you, using the completed handler is a lot simpler. Otherwise, you're having to catch tons and tons of different exceptions. So it's just a lot easier inside of the completed handler. Another good tip is you're going to wonder how you can actually force code to run on your UI thread. Save off your UI thread dispatcher as soon as your game starts, and then you can call run async on it, and anything will run on your UI thread that you need. And then just quickly, in graphics programming, I would highly suggest that you get a device for each of the different manufacturers out there, NVIDIA, Intel, the Qualcomm for your ARM devices, just because each of them acts a little tiny bit differently. We've seen a few things here and there. Some of them have been huge, where it's like the game's running at 60 on one device and it runs at 1 frame per second on another. So we've found some significant things. Hopefully we don't run into those again, but I would just suggest that you guys, if you're about to release a title, that you try and test it on a wide variety of devices. Use the simulator because you won't be able to stretch it out to the same dimensions that the simulator can. Scaling is pretty important, and another really important thing is make sure that you don't just build your shaders for Shader Model 4, Shader Model 5. A lot of the ARM devices only support level 9.3. So make sure that you build at minimum Shader Model 4 level 9.3, and otherwise go to Shader Model 4 level 9.1 for maximum compatibility if you can. But otherwise, you won't be able to run on some of the ARM devices out there. So when we got started, I'm just looking back real quickly, Windows 8 still had a start button. Visual Studio still had color. Wasn't just a monochrome system. So the only things that we did to get started were we took our PC pipeline, our XP Windows 7 pipeline, and we added a D3D11 renderer to it. We added an Xaudio 2 renderer to Xaudio 2 support to it, and those were great adds just outside of the Windows spectrum. So that helped us a lot. We took our code, like I said, chucked it into a D3D11 application and a C++ application, and things just exploded horribly. We got a ton of build errors, but we figured it all out. Run the Windows certification toolkit, and it'll tell you all the prohibited APIs that you're using. You'll find mappings to what you should be using in the future. And luckily, we were using really early prototype versions. There were compiler bugs, there were various things when we got started. We were really excited and got moving early. But definitely go to dev.windows.com. It's got everything that you need. I would highly suggest that everybody starts with downloading the XAML DirectX 3D shooting game sample. It's probably the best sample that they have out there. It has implementations for everything. So it's got Xaudio 2 already in there. It's already rendering using D3D11, and it's got all the input stuff in there. So if you just wanted to take a small game from another platform, I would suggest that you basically take that and just chuck your code in there and look at how they do it, modify your gameplay, and you'll be good to go. So yeah, that's about it. I just suggest that everybody install Visual Studio 2012, make a C++ application or start from the samples, and don't be afraid. Thanks.
Thanks, Richard. And Richard flew here all the way from Australia, and yet he's talking about vertex buffers and shader models and exploding code. So I have to hand it to him. So because we love you, we try to make sure you guys get the full spectrum. So you heard about design, now you've heard about development. You heard about someone who is sort of first party, who also is an independent developer, but now you also heard from somebody that started from third party. And then you heard from someone who wrote their own engine. Next, you get to hear from somebody who writes an engine for you. Richard referenced these guys. Again, these are probably among the most important, if not the most important, third-party game engine you guys can use. It's an amazing tool set. And so with that, it's my pleasure to introduce Randy Spong from Unity.
Thanks, Justin. Good afternoon, everyone. Thanks for sticking around through lunch. So I put my notes on my laptop when the screen literally just died on me here while I was doing this. So while I'm trying to boot it back up, let me tell you a little bit about myself. So as Justin said, my name is Randy Spong. I am a field engineer with Unity Technologies. And you might wonder why a sales guy is out here telling you about the technical process of porting Unity to Windows 8. Well, the reason is because I actually work quite a bit with Microsoft. I am sort of one of the biz dev contacts for Windows development specifically, and so I tend to have a lot of interface with folks around here. But so yeah, let's talk about this new platform story here. So Unity is all about reimagining gameplay. Just like Windows 8, as everyone's been saying, is we're reimagining gaming, we're reimagining the interface. Unity is very similar to that. So I think it's pretty cool because we have the ability to kind of force multiply here and take our reimagining and combine it with Microsoft's reimagining, and we can reimagine the reimagining. It's kind of neat. So in order to kind of convey what's going on here with porting Unity to Windows 8 and why this is interesting, I need to tell you a little bit about Unity first. So let's talk about that real quick. So first off, we're democratizing game development. What does it mean to democratize game development? Well, what it means is we're giving you affordable tools to allow everyone to create rich, interactive 3D content. And these affordable tools are available all over the place. It's really cool stuff. But that's only kind of, it's really more, frankly, that's kind of democratizing software downloads. How are we actually democratizing the technology? Well, the way we do that is by doing the hard work, so you don't have to. We want you guys to focus on gameplay. So we have built out this engine with graphics, 3D, got some 2D stuff in there, more later. We announced on April 1st this year that we're adding 1D support, which is really cool. It's going really poorly, though. We've got physics, we've got light mapping, we've got audio, we've got networking. There's millions upon millions of lines of code in this engine. And oh, by the way, it also runs on 19 platforms right now. We've got 9 core platforms that we've already shipped or shipping very soon. We've got 7 platforms in Union, and we've got 4 platforms, including Windows 8 and Windows Phone 8, that are shipping very soon. And of course, there's a whole bunch more platforms on the other side of our doors that I can't tell you about. So there's a lot of code here. But when Microsoft came to us and asked us to get in early and go ahead and port Unity to Windows 8, we originally were like, okay, that's going to be great. And we went and we did it, and it ran fine. And then the blacklisting apocalypse happened earlier this year when Microsoft went ahead and disabled a few thousand function calls in the Win32 API. So let's talk about what Windows 8 is and how it differs from other platforms and why it's interesting for those reasons. So, first off with Windows 8, it's got touch. Touch is really awesome. I have been using a touchscreen Ultrabook for a few months now. I have my Surface. I got it on Friday. And on all my other computers now, I find myself sitting here and typing, all of a sudden I try and do this. And it doesn't work. Really frustrating. I'm going back to my Ultrabook. It's got tablets. Windows has never really been portable before. Okay, you saw somebody and they maybe had a Windows 7 slate somewhere, but you don't really see that very often. You got Androids and iPads all over the place. Well, now you got Surfaces and all the third-party devices. People are going to be mobile with their Windows gaming. Like Tammy was saying, this is a big deal because people can play their Windows games anywhere. We've got sandboxing. Sandboxing sounds horrible. You got to do a whole lot of work to make your app run on Windows 8, right? The great thing is, though, it's good for the users because they're going to trust your app. They know that when they see something sandboxed, that it's going to be a good software citizen and that it's going to tell them clearly about the information that it's collecting. They're going to be a whole lot more free to download your game and try it out. And, of course, the App Store. App Store is really cool because they've got a demo button. So you can make your game, and you can go to the App Store, and you can say, I'm not sure if I want to buy it. Try the demo. Click the button. One-click install. Like it? Pay the money. Boom, converts over. This is a really big deal, and it's very different than the App Store ecosystems for other platforms. I think this is a really cool thing. But there's always some trouble. It's not always unicorns and rainbows. So, what happened to us is we originally did the Windows 8 port, and everything went swimmingly. Then we got these APIs blacklisted. Well, interesting thing about Unity, we run on Mono. Mono is an open source implementation of the .NET runtime, and it's maintained by an open source community of very excellent coders. But it doesn't work at all on Windows 8. So that's kind of a problem. So we kind of went through and looked at all the issues, and we saw that first off, all the blacklisting, we're going to have to rewrite a whole lot of code. Thread management functions. We use create thread, sleep thread, etc. To do garbage collection. Well, if you can't sleep threads, you can't do garbage collection. So we had to rewrite everything in WinRT. We didn't have WinSock anymore. We had to write everything in the WinRT version of the APIs. There's a whole lot of code we had to rewrite. But then we were looking at it a little further, and we realized that Windows 8 and Windows RT requires you to run an ARM Thumb2 only mode, which our version of Mono does not run in. So now we're kind of like, maybe we should look into porting to .NET. And so we did. We actually spent the past 6 months rewriting the engine. Every part of it that interfaces with Mono now interfaces with .NET as well. So we have this highly pluggable engine. In fact, we were able to throw away a whole bunch of code. We got some performance benefits because the WinRT VM is actually a little faster than Mono. So we actually have extra CPU cycles to work with, which is really cool. And we've been working on our Flash port for 2 years now. We're still not done. It's going to be Windows 8 if we count the second iteration of writing it when they did the blacklisting. It'll be about, let's say, 8 months to port the engine over to Windows 8 and get everything working wonderfully. And we're already in beta right now, and it seems to have gone really swimmingly. So yeah, it was definitely a bit painful. In fact, there's some really interesting specific things we had to go through to get our stuff up and running. So we have some interesting legacy things we do. Our engine's been around a long time. We do constructorless initialization. So we actually will allocate an object, serialize into it, and then call the constructor manually. You can't do that with Windows RT. So we had to write a little plugin that actually injects default constructors into all of our user code. So we actually go and analyze their assemblies, and we just pop constructors in there. Not the most nice approach. We're probably going to have to get rid of this technical debt and rewrite it to actually use constructor-based initialization. Well, just one problem at a time, right? Now, there is a downside to the WinRT VM in terms of native managed interop. It did get slower in Windows 8, and so we have historically been a little bit lazy about our frequency of interop calls. So right now we're working on cutting the number of interops we make in half on a per frame basis. And we're also analyzing some techniques to make interop hopefully a couple dozen times faster. So all in all, at the end of the day, we're probably going to have a net performance boost. But this has definitely been a little bit tough in the initial porting process. And of course, having code go away is never pleasant. Of course, hash tables, array list, things like that, these are APIs that have been deprecated for years. You shouldn't be using them. Unfortunately, we are using them, and all of our users are using them. Easy fix, we just rewrote everything to use dictionaries, et cetera, and then we just wrapped our implementations of hash table, array list, et cetera, in dictionaries as well. So it's one of those things to look out for. It's usually not really that bad for us. It was pretty interesting. We're kind of a big engine with a lot of customers, though. So things tend to be a little bit more difficult for us. I think that I can say that, in my opinion, it takes about 5 times as much effort to maintain a commercial middleware product as opposed to doing it in-house. And so all we have to do, that's great. We just have our engineers work 2.5 times harder, 2.5 times longer. So it's all fine. We also didn't have a DirectX 11 renderer. That took more than a day to write. Yeah. But because we did all this work, because we took DirectX 11 and we built in the DirectX 11 renderer for Windows 7 and Windows 8, we now have a compute shader pipeline that fits right into our automatic shader generation system. So you can be writing crazy compute shaders to do all your tessellation and weird stuff you want to do there, and we're just going to go ahead and generate the shadow code and the lighting code and just patch it in automatically. So again, you get to focus on reimagining games with great new visuals while we do the dirty work. WinRT component support, we're talking about charm bar, live tiles, the split window system. These are all features that we certainly can and will write scripting APIs to natively support. But like Richard said, we're not necessarily going to do it right the day you need it. So having support for WinRT components allows you to write this integration code for any native platform features, and you can just make it work on day one. And then we'll eventually get the scripting API, and we'll democratize the game development there. Multi-platform input APIs, really awesome. Anybody who's written a multi-platform game knows that writing your own input system and making it behave the same across all these different types of devices and form factors is less than pleasant. So the fact that we can have the touch API and the keyboard and mouse and the game control APIs be identical between all touch-enabled platforms and all keyboard-enabled platforms is really awesome for developers. And of course, support for Intel and ARM. This is actually one of the really, really cool parts about our porting Unity to Windows 8 is that we basically get Windows RT for free because we root everything in .NET and it just runs. Well, it's a lie. I'm probably going to get smacked by the engineers, but oh well. It's actually pretty cool, though. It was a lot easier than we thought it would be. And internally, our favorite thing at Unity is that we can now, in Visual Studio, debug C++ and C# at the same time. This may not mean a lot to folks like you who have been doing this for a few years, but being based on Mono means that we had to run 2 separate debuggers at the same time, Visual Studio for C++ and Mono Develop for C#. And you can't do that. So you get one or the other. If you try it, you'll crash. So we're really, really excited about that. In fact, there's even more benefits for us internally. So for example, we're thinking of porting the entire Windows editor to .NET. Because that means we can then debug the editor's C# and C++ code at the same time. We also get the performance advantages of the WinRT VM. So that's going to be really cool for users as well. And of course, again, debugging in Visual Studio 2012 is so awesome. But let's talk about what it does for users. You can do the same things. In fact, you can also use the profiling tools. So now for managing performance, you have the ability to get in there with these really, really awesome tools that are being used by millions of developers and being improved by thousands of developers, and use those to maximize the performance and quality of your game. So the Visual Studio support, I think, is a really, really big deal for this. And of course, you can integrate into the App Store, which means you get discoverability, you get user trust, and you can now just go ahead and focus on making gameplay because publishing is all built in. So we're not shipping quite yet. We did miss the launch, but we're shipping very soon, and we're currently in beta. And if you guys have Unity projects that you're already working on and want to start getting them in there, drop me a line and we'll get you hooked up. Thanks so much.
Thank you, Randy. All right, so as you probably heard, part of the theme here is these guys suffered so you don't have to. They were started very early, some as long as a year ago, some even before that. And so hopefully you found this useful. We did these case studies very specifically because they did invest a ton of effort and pain in figuring out how to really reimagine gaming on Windows 8. They're here so you guys can learn from them. We unfortunately didn't leave time today for us to do a Q&A. We will be over in the networking area. And so feel free to join us there if you have any questions. And finally, I will say really quickly, I'll show you, where is it? Here we are. There are resources available. So again, you may have seen this slide before, but design.windows.com, MSDN has some good stuff. Again, videos at Channel 9. The very short version here is there's a massive opportunity for all of you guys to reimagine your games, or if you're thinking about developing games, to do it in new, interesting ways on our platform. And so we look forward to helping you do that. And thanks for all coming. Take care.